welcome to our live stream.
Hi,
I'm Alfred,
I'm Sumrine.
and this is episode 110 of our Matrix live streams. So in this episode, we will be interviewing Joe Dureau, who is the CTO of Snips.ai. And then after the interview, we'll give some announcements of some cool things that have been happening lately. So yeah, to intro Joseph, he's an entrepreneur and scientist. He's now the CTO of Snips. And Snips is a voice interface for connected devices that works on device, offline, and is super privacy centered, just making sure that the end user data privacy is all there. You've heard us talk about Snips a lot, so now we'll be interviewing their CTO. And before joining Snips, he founded Standard Analytics, which is a platform for connecting all of the scientific knowledge out there. He also worked for NASA, he worked for the CEA, for the Bill and Melinda Gates Foundation, and at some point he actually taught literature at a prison. He holds a degree from École Centrale Paris. I don't speak French, so I probably butchered that. And a PhD from LSE. So without further ado, here's Joe. Hey Joe, how are you doing?
Hello, good.
Great. So yeah, thank you for joining us. I guess we can get right into it. Love it if you could just explain for our viewers like what is Snips and what are like the primary features of Snips and everything.
So Snips is an embedded voice interface for connected devices, and what's specific to it is that it runs all locally. So none of the voice goes to the cloud. We don't need that. Everything is processed locally, so that you can activate actions, devices, or services directly from the device you're talking to. So that brings a lot of things. First of all, latency, so you don't need to do a round trip to the cloud. Then privacy. There's no fear that what's happening in your house is going to be listened by someone else. Right. And something also that we propose is performances that are the same level as what you get with Amazon Alexa and Google Assistant, but in a white label way. So today, if you're a device manufacturer, you want to add voice in your device, the big thing you need to choose is either you're going to sacrifice your brand by taking Alexa or Google Assistant, and then when people are going to talk to your device, they're going to call it Google, or they're going to call it Alexa. Which in terms of brand, it kills everything.
Yeah.
I do that, or before we came, you had to either choose that or experience, going for a technology that was less performing than Google and Alexa. So with what we propose, you have a third choice, which is actually a white label assistant. So you can put your voice, you can put your wake word, and the performances are going to be super high, and you're not sacrificing your brand, nor your user's privacy. So that's Snips in a nutshell.
Yeah,
Nice.
that's a really actually a nice way to sum it up.
Yeah. And I mean, we have like the Matrix Voice, which has the 8 mics and everything, and we see a lot of people using Snips for that exact purpose because they're developing some sort of product and they don't want Google or Amazon anywhere near it. Imagine if you're trying to put it in a retail store, like Walmart or something. Like they don't want Amazon there.
Yeah.
So that's where Snips plays in perfectly.
Yeah.
And then especially with the privacy, like all the issues lately. I don't know, did you see the article a couple days ago of Apple had an issue with FaceTime, with group FaceTime calls, where you call somebody and then you were able to hear their audio without it accepting the call.
What?
Yeah, that was not a good thing.
No, and actually this kind of news come all the time. It's crazy. We've been working on privacy and AI for several years now. Like these days, like it's really week after week, there's a big story that comes out.
Yeah.
Actually, you mentioned Apple. Usually, they're the good guys on that side.
Yeah.
We're actually quite aligned on all the embedded processing and respect for privacy. The most news on that side comes more from Facebook.
Yeah.
And things like that. Something interesting is, as a startup, actually we had no choice. So we actually manipulate very intimate data, right? Voice is biometric. So for us, we had two choices. Either we would do like the others, bring it to a server, but eventually we would get hacked, right? Because as a startup, we have no way to protect our data. So for us, it was a no-brainer. We had to find a different way. But people were telling us, okay, so you guys have to do that. But big companies, they can protect their data. And the example that was always given is Google.
Yeah.
Okay, yeah, maybe you have to do that, but I trust Google with the data. They can have all the data they want. I trust them. Until last year, when they got hacked and had to, and actually tried to hide it for several months.
Yeah,
But
with Google
that came
Plus.
out. So actually, there's no one that's too big to be hacked.
Right.
So that's why we're basically investing on technologies that you could call. There's two words for it. So we call it privacy by design. So there's nothing that can be done about it. The way the system is designed is that we don't even have the data, so we cannot be stolen the data.
Right.
Another way to say it is that the system is based on zero trust. You don't need to trust us for the system to work.
Yeah.
Those kind of new concepts are really interesting because they provide a way to have rock solid solutions in terms of privacy. Nothing can happen. And the second advantage of that is that it democratizes the possibility for anyone to provide solutions.
Yeah.
You don't need the huge infrastructure that Google has to protect data. We just don't have it.
Right.
Yeah. Yeah, it's great. I mean, with that, anybody can make a voice assistant device, like whether you're like a kid, right? Just using the Snips console, like setting up the assistant and everything, or you're some big company just trying to make a product but don't have the resources of Google.
Yeah.
And so part of that, a big thing of you guys is running on like low power devices like the Raspberry Pi, like a microcontroller. So could you talk more about like how you guys have worked through like getting the algorithms and everything to run on a Pi and things like that?
Yeah, so that was a huge challenge. So as I told you, we had no choice. It had to run in there. We always mention the Raspberry Pi 3 because it's not an industrial device. When you go to big device manufacturers, they're going to use equivalents of that are more industrial grade. But that was the right order of magnitude because it's basically a mid-end CPU. So it's not the low end that's going to be deprecated in a couple of years, but it's not the high end either that's going to cost too much to be put in a device. So actually, we wanted something that you can put in every day-to-day device. So that's going to be a TV, a set-top box, these kind of things. That's a kind of the order of magnitude of the processing power that you find in there. So we needed to fit in there. So we started working on voice 2 years ago, and the first year was really about bringing the technology to the level we wanted it. So we wanted to have the same performance as Google and Alexa by running embedded on this kind of device.
Right.
So the way we did it is we had to take compromises or to take shortcuts in some directions to do things differently to achieve the same result. So there's basically two elements to the secret sauce of Snips. The first ingredient is contextualization. So basically, if you take a voice interface, you have two bits. You have speech recognition that translates sound into text. And then you have natural language understanding that takes the text and outputs the intention and the parameters of the intention. Okay? So the classic approach is to have one-size-fits-all ASR, so speech recognition engine, that has a huge vocabulary, can understand basically anything, translates into text, and then the NLU knows about the domain and what the user is going to talk about, and generates and processes it. So basically what we've done is just we go from the ground up. So we take what the NLU has been trained for, so all the intentions it is meant to recognize, all the vocabulary it's meant to recognize, all the formulations that are possible for those intentions, and we actually use that to contextualize the ASR. So the ASR is not a one-size-fits-all. It's whatever you want it to understand, it knows about it, it knows the context, it knows the domain, and it uses that to maximize performance. And that's how we can have similar performances while having a much lower footprint.
Interesting.
So we did a benchmark where we compared to Google Speech to Text, which is basically the reference in terms of speech recognition engines. And we compared it on maybe the most common, but also the hardest use case for voice interfaces, which is music. Music, the vocabulary is huge. On Spotify, I think you have over 50 million songs.
Wow.
Okay, so no way you can put that many words in a speech recognition engine. So we're like, okay, if we do as well as Google on that, that means that there's nothing too big for us. So we compared, and we're actually doing much better.
Mm-hmm.
Wow.
Which like makes no sense. We actually, the reason why we're doing better is their engine is able to recognize music as well as so many other domains. So actually, if you talk about an artist that's in the top 1,000 in terms of popularity, they're going to be as good as us. So they know them, they recognize them. And if you go down in terms of popularity, if you go to 5,000 in the ranking or 10,000, they're failing more than 50% of those.
Wow.
Okay, because actually those names, those words, are being in competition with other words that sound similarly, but are used in other contexts.
Yeah.
Okay, so we actually, and the same way you and I, when we talk, we know, we know the environment. We know we're talking about tech. We know we're talking about voice. So even though I have a crappy French accent, you actually understand what I'm saying. You're using that context.
Yeah.
It's exactly the same for our technology. We use the context to make sure that even though we have less computational capability, we can have the same performance.
And how
So
do you
yeah,
guys
that's the secret.
and how do you guys deal with like not getting confused with other words that sound similar? Because since you guys don't have that huge library, you can't pick out every word, right? So how do you deal with that?
So there's two lights to that, and in machine learning is always the same thing. It's uh, recognizing positives and recognizing negatives.
Mhm.
So if you're talking about two words that sound similar, but that are in the domain that you're meant to recognize. So let's say two artists that sound similarly. Well, basically, it's like you and I. We have ears, so we have an acoustic model that's going to tell us that what the guy is saying sounds more like the first one than the second. So basically, we have that acoustic model, which is basically the first layer of your ear that has that ability to distinguish sounds. So that's going to be okay. And
Okay.
then the second problem, which is about failing gracefully. So when you have a word that's out of domain that looks like a word that's in domain. That's much harder for us because those out of domain words, we don't know them. So the first assumption we make is that people are going to ask things to the assistant that the assistant is able to deal with.
Yeah.
Okay, so out of domain should be less frequent than in domain. And then well, it's a hard problem. That's ongoing research for us and actually for everyone in the industry. Try to trigger any voice assistant out there and just talking nonsense. It's going to project that nonsense to the thing it expects.
Yeah.
That actually is the state of the art. So I'm not going to lie, we don't have a strong solution to that. Actually, no one has today.
Yeah. But hey, I mean, something to work towards.
Exactly. Yeah, trust me, some people are busy on that
I, I
here.
I bet. Great. So we're talking about the ASR, the NLU. So on the topic of getting back to like running it on like low power hardware, have you guys tried looking into running Snips or at least parts of it on like a microcontroller or an FPGA?
Yeah. So on the microcontroller, definitely. FPGA, not yet. So microcontroller, we can run on a M4 or M7.
Okay.
What we run is not exactly the things I've described so far. So you don't have a large vocabulary understanding on these kind of devices. But for many things, for many day-to-day devices, you don't need that. For smart appliance, for your washing machine, you're not gonna
Yeah.
philosophize too much. Like
Yeah.
you need the right words. So we call that voice commands. So basically, you need to be able to turn on, turn off, start at 30 degrees, things like that. So quite restrained. So yeah, today we can do these kind of things on a microcontroller. And just to give you a little bit of background, the way these models work today, and that's the state of the art, they work in a very similar way as wake word engines. So the thing that detects, okay, Google, hey Alexa, or hey Siri, or whatever.
Yeah.
These things are pretty dumb models. Dumb, I shouldn't say that because it's a really hard problem, but still, because they run all the time, because they listen all the time,
Yeah.
the neural network is super small. So that thing doesn't understand what a phone is or what a sound is or what a word is. The only thing it does is it compares what it listens to large data sets of people that we've collected here saying the same word. So when we want to train a wake word, we ask 500 people to repeat the wake word 5 times. Okay? So we have that large database of possible ways to say the thing, and that database of sounds, we just compress it into a neural network, a small one, and the wake word just basically detects the same signal. So it doesn't understand anything, it just compares the signal to that.
Okay.
So today, voice commands, the thing we run on an MCU, work in a similar way. So if you want to understand 30 commands, we need to ask 500 people to say those 30 commands 5 times.
Yeah.
So that's quite expensive and quite long in terms of data collection, but that's the state of the art today. But we're working on a solution, which is going to basically change everything, is to put the same technology we use on ASR, transpose that on microcontroller. So basically you have a very small acoustic model that you train once and for all that is able to recognize sounds. And then behind that you put a language model that is basically the 30 or 50 commands you want to detect. And it's going to work the same way as the bigger brother that runs on the Raspberry Pi 3, but on a microcontroller.
Wow.
And the advantage of that is you just, you're going to be able to go on our console, type the words you want to detect, you click on a button, and there's no data collection, there's no model training. The thing is going to be instantaneous. The same way that when you train an assistant on the on the Snips console today, you just put your examples, and when you're happy with it, you click on the button, you have it instantaneous. It's going to be the same thing for microcontrollers. So that should be a game changer in terms of capturing the long tail of all the devices in which you don't want to put the CPU and for which a microcontroller does the job. That's going to be, so I'm quite excited about that technology development we're working on.
Yeah, that would be huge. Cool. And so that would be running on a M4, M7 as well?
Exactly, yeah.
And then what about like in FPGAs? Have you looked into running them directly on the FPGA or on like an FPGA replicating a microcontroller?
Not yet. To be honest, the history of the companies, we come from the software world, so our engineers actually they come from the mobile world. So we're used to like powerful devices, so that was fine. 2 years ago, we told them, okay, guys, we're going to go a little bit smaller. So they went on the Raspberry Pi 3. Okay, we adapted to that. Last year, we started working on microcontrollers. Okay, so we're getting used to it. But the smaller you go, the less mature the technology also and the environments. And so it takes a lot of energy to support every new board because it's not really standardized. So everything you need to redo. There's a lot of friction in supporting a new architecture or a new hardware every time when you go down like that. Yeah. So FPGA, definitely we're going to look at it at some point. But today we don't have the resources for that. So we're really concentrating the efforts on M4 and 7 actually.
That makes sense, yeah.
Okay. And then do you guys already have the voice commands out like on your website for people to be able to use?
On the enterprise websites, yes.
Meaning
any company can come to us and buy that technology. On the console, not yet. So people cannot go. Actually, we're waiting for the technology I mentioned, where you're going to be able to just type your words, click on a button and get the model, because that's really the experience we want to provide. So until we get there, we're not going to expose the console to the users. But when we get there, definitely. We're also starting to think about the same thing we did with developer kits, where you can buy through Seed, for example, a Raspberry Pi with a microphone and get it at home and you have your device. We're thinking of similar kind of kits with a microcontroller on it. So that would be interesting for,
Yeah, you should contact us about that. The voice has a microcontroller. The Matrix voice does. And an FPGA, if you...
Yeah, so definitely. Those are things we're going to look at. Because we really want to empower the community with using our tools. So that's a bet we did from the very beginning, which was give the tools and make them available to the public. So for people who don't know, the Snips tech is free for non-commercial use, which makes that anyone who wants to tinker at home, they can use and play with it. They have straight access. So that's what led to having a community that's over 20K people
Wow.
big over the last year. So that's a number we're pretty happy with, and there's a lot of things, a lot of good feedback coming. And another nice effect of that is that we're actually getting into meetings with potential clients. That happened again last week. We get there, and I go there, and I'm ready to explain the technology. And the guys say, "Yeah, don't tell me about your technology. I know it all. I've already tested. I validated. I'm happy with it. Just tell me the price." And we're like, "Ah, okay."
Yeah,
Nice.
yeah, that's
Uh,
great. It makes selling easier.
Yeah. So actually, that's an advantage when you're a small startup like us and you have limited, sales resources. Make the technology available like this. It's actually self-evangelizing. So that's a great advantage we've had.
Yeah. And about the community, what are some of like the more interesting projects you've seen people make, either like assistants or like full out like personal solutions?
Uh, so there, I haven't played, but I heard that there's someone who ported a very popular voice game to Snips. So basically, it's a game where you make choices all along the way. Same like the books you had when you're
Yeah.
a kid, where you were the hero and you make
Like
choices. He
Bandersnatch.
ported that to Snips, and I've been wanting to play that for quite a while. So that's something that I'm pretty curious about. Something fun but quite useless was driving a drone by voice.
No way.
The only problem is, you with a drone you need to be quite reactive. When it's just running into someone's face,
Yeah.
and it's going to stop like this.
Yeah, like up, up.
You need to have the
It's a
backup
very
controls.
dangerous and a bad idea, but it was pretty fun. And also, yeah, there's a guy, and actually we spend more and more time with him, and now he's joining us organizing events, etc.
Oh, wow.
Uh, he's basically his whole house with Snips. Like in every room, he has microphones all over the place, even in the walls. Like he
Oh
went to a
wow.
level of integration, like way further than anyone at Snips has done.
Wow.
He controlled everything. He called that assistant Alice. He's been sharing a lot about what he's doing on his blog post. I really recommend going to read. So the guy is called Psycho. So if you look for it, Psycho Snips has very nice blog posts on what he's been doing.
Yeah,
Okay.
that's
Yeah,
awesome.
I'll for sure look that up.
I think I remember this person reached out to us.
Oh really?
Yeah.
Oh
They
nice.
reached out to us for a sample of our board.
Oh.
Yeah, so that's
People
that's
always want free
interesting.
things.
It's nice.
He's a very good guy to give free stuff to.
Yeah.
Because he does a very nice thing to them.
That's
Okay.
that's
Yeah.
good to know.
We'll get into contact with
Yeah.
them.
I'm curious, like, you know how, like, there have been, like, those, like, issues with, say, Alexa hearing and being triggered from the TV and stuff like that. I mean, with Snips, I guess, like, even if it does happen, it's not as risky because it's, like, can be offline. But, yeah, I mean, are those, like, things that, like, also, like, aspects that you're looking into, like...
Well, not being triggered by TVs is not our first problem today.
Yeah. There aren't
It's a good problem
commercials.
to have when TV talks too much about you.
Yeah, right now it's
a good
like,
problem.
okay.
But actually, reducing the false alarm rates to of the waypoint has been a really hard problem for us, and actually it's for everyone. It's actually because it has a very strong impact on the user experience. The triggers. So you have two negative consequences to it. So the first one, which is basically, I think, the most important and that people don't see, is that whenever there's a false alarm, your device is sending a bit of sound to the cloud.
Yeah.
Okay, and actually that people don't have the order of magnitude, but that happens between 1 time per hour to 1 time per day, depending on the engines you're working, and that happens randomly anytime during the day. As I said, the engine that does that computation is a very dumb one, so it's not because you say something that looks like Alexa that it's going to trigger. Sometimes it's going to trigger with really different things. We had a problem with our Hey Snips wake word. For some time, it was triggering when people were sneezing and when people kids were crying. So
Oh, wow.
I'm telling you,
It's interesting.
it's a dumb model, so it can confuse with very obscure things. It's not a human brain.
Right.
So it can happen. Really, you can imagine that these false alarms happen anytime. So really, whatever conversation you may have, it could trigger and send bits of what you're saying to the cloud. So that it sounds completely off to us. That shouldn't be the way it works. So that's why we're proposing an alternative to that.
Yeah, I feel like that's the interesting thing about machine learning because, like, with CV, it's like, oh, the same person wearing sunglasses and it'll think it's completely different. Or like a stop sign with paint on it and it won't recognize the stop sign. Like, it's a
Exactly,
problem.
those are like adversarial examples. Yeah.
Yeah.
Yeah. So, and the dumbest the model, the more loopholes you're gonna have like that. And the wake word engine is pretty dumb.
Right.
Again, I mean, it's not dismissive when I say that it's
Oh,
one
of
of the
course.
Yeah,
hardest
no,
problems
it's just.
we ever work on. But the thing is so small, so that you have a small footprint running all the time.
Right.
That you have this kind of limitations. It's intrinsic.
Mm-hmm.
But actually, something that we're working on these days, so is something that we can do because we're local, is actually to remove the wake word. Because today, actually, if you think about it, the main reason for the wake word is to trigger a streaming of the sound to the cloud to run speech recognition.
Yeah.
But we don't have a cloud, so we don't need to know when to start triggering streaming to the cloud. So actually, we could be listening all the time.
Right.
And because it's local, nothing happens.
Yeah.
It's just like instead of having a wake word running, you have the speech recognition engine running. And actually, you could imagine much more natural interactions with the device.
For sure. Yeah.
Typically, instead of using a wake word like "Hey Siri," so why say "Hey"? I tried teaching that to my grandmother. She was like, "Hey, why? So if it's called Siri, why do I need to say "Hey"?" And she was saying Siri, but at the middle of the sentence or at the end. Because when I'm talking to you, I'm going to use your name to just like notify you that I'm talking to you. But the really natural way is just to use your name and to put it anywhere in the sentence.
Right.
And actually, that's something we can do by being local. So that's something we're currently exploring, and that could provide a completely different way of interacting with objects that would make it much more natural.
Yeah.
It's
So
more like you're
that's an
talking to a
interesting thing
human.
that
Yeah.
Nice.
Actually, it's possible today. Anyone can try it at home. So it's a bit high-tech, but with the Snips platform today, you spend an hour on it. You just relaunch sessions every time a session is closed. So start listening, it ends, you restart a new one, and you do that all the time. And you're gonna get signal. You just need to filter out the crap. So when it doesn't, when it's interpreting wrong things. But today, you can code that kind of logic with the current solution you guys have at home. It's possible. So if anyone wants to play with it and get back to us with their results and experience, I'm happy to hear the feedback.
Yeah, I could try it out. I'm actually working right now on a project in my home, basically using Snips and a Matrix voice connected to a light switch that I have. That's one of those like long fluorescent tubes, so I can't like replace it with a smart bulb. So instead, I'm wiring it up so that I can use a relay and Snips, so I can tell it, "Hey Snips" or Jarvis, because that's one of the wake words you guys have, so that it turns it on and off. So maybe I'll try out having turning on and off the speech recognition,
Cool.
so that it's more natural talking to it.
Yeah, well, let me know.
Yeah, for sure. I mean, I hope to finish the guide for next week, for next Wednesday. That way we can discuss it in our next live stream. But we'll see how that goes. Cool. So one last thing was we've talked about your community and how big it's grown. It's like you said, it was 20,000 people at this point. Do you have any advice or tips or like cool things that people aren't using that you wish they'd be using more of something? Just something interesting for the community.
So I'm just reacting to what you just said. So you can use "Hey Snips" as a wake word. You can use Jarvis, but there's also the possibility to use a personal wake word. So you can actually define any wake word you want. You can go to the documentation to see how to do that. And basically, you're going to record yourself saying 3 times the same thing, and then that's going to be your wake word from now on. And that's going to work for you. And so if you have several people at home that are going to use the assistant, each one can use its own wake word. That also means that then it's going to recognize who talks to it through the wake word.
That is cool, yeah.
So that also means that you can personalize the experience. So if you're really into it and want to go forward, you can imagine that if I'm talking, it's a certain voice that's responding. If it's my girlfriend, it's going to be a different voice with a different tone. And potentially, if I'm controlling my music, in one case it's going to be my favorite music, and in the other case it's going to be my girlfriend's personal music. So you can really build a personalized experience using it.
That's super
interesting.
Cool. If we ever make something with Snips for our office, we should do that so each of us can control different parts.
Yeah.
You can completely customize it.
Interesting. So if you're training the wake word for yourself, is it? Have you guys seen? Is it any more accurate than the general one when it's like your voice specifically being trained?
The experience we have is that you get similar rates of false alarms.
Okay.
So actually, you get similar kind of performance. The big limitation of that thing is that it will only work for the person who spoke in the first place.
Okay.
Because you really have those 3 samples, and it really looks at the signatures of those 3. If it's someone else who says the same word, even if you try to imitate the first person, it's quite hard to make it trigger.
Okay.
On the other hand, I'm not promising any security skills of that, so don't protect your home based on that.
Yeah, it's not a security feature.
That someone else manages to trigger it.
Yeah.
So it's not really a feature of the thing that is going to recognize you, but it's more a limitation that usually it's only the person who trains it in the first place who can trigger it. But you can have as many as you want in parallel, so everyone can have their own.
Yeah.
That's not a problem.
That's super
cool. So I'm gonna look at the chat here on YouTube to see if there's any questions.
We have people who might be asking questions, so it could be a bit interactive.
Let's see. Google's one. Confirm that. Oh, someone confirms that when they sneeze, Hey Snips gets triggered.
Wait a few weeks and
wait for an update.
Nice. So does anybody have any questions?
Yeah, if anybody has any questions, please put it in the chat now. But while we wait for that, do you have any final remarks?
No, it was great chatting. So yeah, keep feedback coming. Thanks a lot for pushing the Matrix. It's a great device. So it's good to have these kind of tools for anyone to play with. So yeah, the more we engage with the right tools like this one, the happier we are and the bigger the community. So keep it coming.
Yeah, we agree. I mean, we love Snips. We use it all the time. I don't know if you saw that Iron Man project that we made for Halloween.
Yeah, I saw that. That was pretty fun.
Well, we actually have the Iron Man behind the pegboard that we have here because our conference room is there. So anybody in the conference room sees the Iron Man. If it hears, well, it's on right now. It may turn on, but if you say, "Hey Jarvis, turn on the reactor," it's on, so it'll turn on the reactor.
Nice.
While people are in the conference room.
Actually, now that well, you could put a personal wake word so that you can call it directly by his name.
Yeah, that would work. Tony, turn on the wake word.
Turn on the wake word.
Turn on the wake word. Oh my god, turn on the arc reactor.
Yeah.
I need more coffee. Okay, let's see if any more questions.
How hard was it?
Okay, so Carlos asks, how hard was it to develop for other languages? I'm guessing.
That's a good question. It was super hard. Especially, actually, the first languages were hard. And the reason is simple: is that we had engineers, we had machine learning scientists in the company, but there's something that was missing was linguists. And actually, there was a reason we didn't have them is we didn't even know that kind of thing existed. It was so different. So French and English, we tried to do it by ourselves. Then we started with German. It was like, oh, so complicated. We don't talk that language. So we brought someone who spoke the language pretty well, but actually that's not enough. So computational linguists are actually people who know how to code, know how machines work, and also how have an analytical understanding of how the languages are built. So now we have a couple of computational linguists with us. And basically with them, we developed a playbook to support new languages. So with them, we added Japanese,
Wow.
Spanish, and Italian.
Very
And that was
nice.
much smoother than the first languages we had.
Yeah.
So now basically we have the playbook, so we can add more. It's a matter of resources and priorities. So I know there's people who come ask us about Dutch and other languages that we don't support yet. We'd love to go faster, so it's really a matter of resources.
Yeah.
Okay.
So if there are rich investors in the listening to this live stream, they can call us as well.
They should call us too.
That's awesome. Yeah, no,
Cool.
like,
Awesome.
we're definitely impressed by how many languages you already support. Given your resources, like you said, like it's still pretty impressive.
Actually, it was important for us, to reach as many people as possible. And we're quite proud to say that today we support as many languages as Amazon Alexa. And those
Yeah.
guys, there are 10,000 people in there. So
Wow. Yeah.
that's
Amazing.
quite
That's
an
pretty
accomplishment.
good. Multi-billion-dollar company versus you guys, which, well, aren't multi-billion-dollar company. Yet.
Yeah.
Yeah.
Coming.
Cool. Let's see if there's another question. So one person's asked a couple questions.
So I guess,
Why do you choose a very young protocol like Hermes?
and then run the custom hot word.
So the person asks, when will the custom hot word work on Android?
That's a good question. It's done. It's not public yet. We're collaborating with Mozilla on that.
Oh, nice.
So because they integrated our voice interface to their Things project. So I think it's out there, but they haven't publicized it yet. But if you go see, we're in there. And for that, they wanted to have a personal waypoint.
Right.
So they've contributed the piece that was missing. So it will come shortly. I think all the work has been done is about putting things together and making them public.
Cool. And then they also ask, why did you choose a very young protocol like Hermes? What did that drive? What drive that decision?
Actually, so Hermes is something we developed on top of MQTT. So basically, we developed the abstractions we needed. So we needed our own protocol on top of MQTT to define the messages and how it was built. So the choice is not so much Hermes because that's something we developed. It was more MQTT. And we're quite happy about that choice because it basically allows us to have a completely decentralized architecture. So that's actually what allows us to have satellites and some pieces of the engine running on one device, some others somewhere else. So you can have wayports all around your place on smaller devices. So typically you can run them on a Raspberry Pi Zero. You can put those all over the place. And they all communicate with the hub to the MQTT protocol. So that was, for us, it's a choice that we're pretty happy with.
Okay, yeah. And like when we're building projects, we typically don't use the actions on the Snips console. We get everything directly from MQTT. Just because we're experienced with using it. Some of our things use, well, our things use 0MQ, so slightly different. But it's more or less same concept. So somebody else also asks, if you already have it running, at least the wake word on like an ESP32. No? Okay.
All right.
Okay, cool. I think that's all the questions. Thank you very much. This was great learning about like the NLU, all the amazing things that you guys have going on. I guess, I don't know, can we say already what we're working on? Maybe not yet. Yeah, maybe.
I think we can preview it.
Yeah, okay, so just for our viewers, first time saying it, we're currently working on doing a contest with Snips. We'll be starting that probably March, April, around that time. We'll have more announcements before then. It's going to be a contest on Hackster with Snips and ARM, and so stay tuned for that. But yeah, with that, thank you, Joe. It was great speaking to you, and we can't wait to see what else is in store for Snips.
It's coming. Bye, guys.
Bye.
Okay, bye.
Bye. Thank you very much.
Thanks.
Thank you. All right. Cool.
Awesome.
Let us move to the
to
Front
the other
cam.
camera.
Hello.
Oh, hi again.
Alright, so
Great, that was really cool.
definitely,
Wow.
definitely super cool. You actually did a really good job of explaining some of the
Yeah.
tech. Like,
Yeah, I mean, that's like really complicated stuff.
yeah, definitely not easy to explain. Someone like me who doesn't really know much about machine learning, other
Yeah.
than like what I read in articles
Yeah.
or something like that. So it's definitely pretty
That's cool. That's really
Yeah.
cool. And I'm very excited for Snips running on more of like microcontrollers, like eventually maybe the M3 or like an ESP32.
Yeah, that'll, open it all up for us.
Oh yeah, because then you can have super small devices with the microphones, and even if they're just doing the wake word and they're talking to another device that is still local, that is doing the actual ASR, then it's huge.
Imagine having like the Matrix voice standalone doing like complete like voice like.
Oh, that would be
Snips.
amazing. Yeah, I'd be so happy.
Yeah, that's definitely really cool.
Awesome, cool. So I guess with that, we'll get to a couple announcements that we have. So I already touched on, I guess the first announcement is Dev Day, ARM Dev Day. So last week was this full day of workshops on last Tuesday, and it was hosted by ARM on Hackster, and basically it was a whole day of workshops of us, for example. We had a 2-hour workshop where we went through how to use a matrix creator with Snips, setting it up, how to control the lights on the creator, how to get sensor data, how to get Snips to respond back of like what's the temperature.
The videos should be coming soon. This was the page. If anybody's interested,
so the page is events.hackster.io/armdevday. So you can check it out there. There were a bunch of talks. I believe the CEO of Snips, Dr. Rand Hindi, he gave a little talk. And there were a bunch of other talks, like from, I think, Kwabina from the CEO of OpenMV gave a talk. There was a panel at the end.
People,
so go check it out. They'll be posting the videos sometime this week probably, or start posting it this week. I guess we'll talk to Alex about that. But, so that was great. We had, I think, in our workshop, it was consistently like 200 people watching it, which is really good.
Definitely, yeah.
Yeah,
and Carlos did a great job, like going through the whole thing.
It was perfect. We had practice beforehand, but he timed it perfectly. So right as the workshop was ending, he finished the work. He finished explaining everything. So it was really nice.
Yeah, definitely. Stay tuned for the video. We will definitely send out like some social post about it.
For sure.
Right.
So second announcement is our Matrix kits. So as we've been saying, we launched these kits back in December, and basically it's a nice case with a Matrix Creator or Voice, a Pi, an SD card, power supply, everything that you need in order to get started using a Matrix Creator or Matrix Voice. And we have versions that are CV versions, so they basically include a Raspberry Pi camera. So we've been selling these things like hotcakes. We're actually out of stock right now, but we'll be getting more stock tomorrow. So all's good. If you order now, it'll ship out this week. If you want to purchase a kit, you can go to our website, matrix.one, and check out the kits on our educators page or on our store.matrix.one.
And we'll put links to. I'll switch back to the camera.
Oh, okay.
We'll put links to all of like Dev Day, the Matrix.one, Snips links. They had some links to like their console and some sources of information from them. I'll include all of those in the description, so you can refer back to it later. And feel free to always comment on our videos, and you can also post on our community if you have projects or questions or. Community.matrix.one, which will also be in the description.
Or tweet at us on Twitter. We like Twitter. At matrix_creator.
I think it's just... Is it underscore?
I'm pretty sure it's underscore.
Okay. Yeah, get confused with all the different... Because I think Facebook is Matrix Creator without the underscore.
Is it? Oh
my God. I get confused. But Matrix_Creator for Twitter. I think you're right.
Yeah. Okay, so last thing is this project that I'm working on, which I already talked a little bit about. So basically, I'm working on a guide, which hopefully, fingers crossed, I'll be able to finish it to release next week for our live stream next week. And basically, it's a Matrix voice with some wires connected to a relay, which is controlling a light switch in my apartment. And on the Matrix Voice, it's running Snips. Well, the Pi is running Snips using the 8 microphones on the Matrix Voice for the voice. And then you can tell it like, hey, Snips, turn on the lights, turn off the lights, so on. It's pretty simple. It's a simple guide. I'm finishing up, just cleaning up the code now, making a nice 3D printable enclosure so that you can have the Matrix Voice like replacing the light switch there. And of course, like once you have it there, you can always go on Snips into the console, add more features.
Personalize your wake word.
Yeah, so lots of things you can do once you have that. But this is a cool use case that I've actually had this working in my apartment for probably like 5 months at this point. But I haven't gotten around to finishing it. So, okay, goal is to finish it for Wednesday.
Yeah, and then we can do a live stream on it.
Yeah, and we'll release a guide and do a live stream next week on it. And yeah, so I guess that's about it. Next week we'll be having a live stream on Wednesday. We'll release exactly what time it is, probably around 6, 7 p.m. EST. Yeah, so with that, I guess that's it. Thanks
Bye,
for
guys.
watching. Bye.